My name is Robin. I work at News Store, and I'm fascinated by Jest. I'm fascinated by the ability to introduce awesome features at a rapid speed. And it makes it difficult sometimes to discover new features. And whenever I do, I go around and I tell everybody about it, and they usually go, "What? I didn't know Just could do that." Or they say, "What? That elegantly solves my use case." And sometimes they do like, "What? That was the worst winning speech ever." But I'm just fascinated by Jest. Today I want to share some nice tricks and tips I've learned. Maybe you know some of them, maybe you don't. I have 4 topics I want to cover. I sometimes read the specs, I sometimes follow the PR, so the last section is about some sneak peek to the next version, something already emerged but not released. I mean, if you wanted to leave early, don't. I guess I can use the computer now. Let's start with what is Jest. Just they describe as a delightful, battery included, zero configuration testing framework. It was developed by Facebook. It plays really nicely with React and other Facebook technologies. It's built on Jasmine and Expect. By the way, Expect was eventually donated to Jest, and a few months ago they forked Jasmine, so now it's a bit separate, and now everything works it did before. What I really like is that they care about developer experience. They introduce pragmatic things which maybe are not sometimes, I don't know, like pure or something like that, but they solve your issues and they really have this target in mind. First section is about snapshot testing, which I think changed how we test React applications. I assume most of you heard about that, so let me quickly go through what a snapshot testing means. A snapshot test is something that takes an object, let's say a JSON, takes a picture of that, and saves this picture. Then, when you run the same test again, it takes a picture again, different picture, maybe the same, and it will tell you, the picture I took is different. This picture can be of a React component or some other data structure. Let me see how it works. So here I have a test. You see some describe, some test. Then I have an object with very different primitive JavaScript values. And on the bottom, I have where I actually use the test, where I use the snapshot. It says I expect this thing to match the snapshot which was saved. To match snapshot is basically no different from any other matcher, like to be equal or something like that. What it does is, when you run it, it will generate a file, which will look like this. It will stringify, serialize, however you want to call that, the object, and you can compare the differences. You can see that it takes the name of test to the name, so you see method works 1 and method works 2. So that's the order of the snapshots. Let's go through the primitive values, because okay, first thing, we snapshotted an object, and you can see that the properties I sorted alphabetically. That's actually really cool. I had some problems with that before, but it's solved. We can see that it works for functions, for maps. It has this. Oh yeah, for functions. You see that? You only see there's a function. You don't see the implementation. You don't see how many. You don't see the arguments. You don't see the name. There used to be a name a few versions back, but there were problems with different node versions, so they removed that. That's important to know. Function is not like snapshotted as it is. It's just a function there. With a map, it's different. You can see you have some way how to have key and value pairs. The same with the promises. The promise is the same as function. You have no, like nothing. The promise was rejected. It was fulfilled. Whatever was there, you don't know about that. You just have, here's a promise. It's important to know about this. With set, again, you have all the data. What is interesting here is that the symbols are also snapshotted, and they are on the bottom. That works. You want that. You also see that you don't get anything from the prototype. This is just like the OM keys, or whatever you want to call them, OM keys and OM symbols. Next, the nice thing is that the names can be customized. So before that, you had the name generated by the test itself. You can pass an argument, which is a string, and it will use this name globally. That's interesting, so you can move snapshots between tests and compare it. However, it will always add the index. So if you can have snapshots named the same multiple times, but the numbers will be in the order of execution. Here I have another tip I really like, and it's with calling functions. On the top, we create a mock function. You can know it by the name spy. And then there are two ways how to kind of test what happened. The first one, we look, has been called with this arguments, has been called with these arguments, and it was called twice. What we don't know, for example, is the order of the calls, because if we switch the order of the function calls, all of these things would be true. The trick I have is that you can actually make a snapshot of the mocks.calls object. It's actually an array, and it saves array of array. It's calls and arguments. So here you see we have two calls. First call with one argument, second call with two arguments. This will like totally snapshot, like it will concrete the whole thing. You cannot change anything. You cannot add more calls. You cannot add more arguments. You cannot switch them. Whatever. It's like totally bulletproof. As I said, Jest includes snapshot testing for React and for immutable by default. That works really nice. For React, you can have snapshots like these. So you have this. You don't have function calls. You have the result of those. With depending on the props. With the immutable, you get these nice names as well. Another question is, can I use this for me? Can I somehow write it? And the answer is obviously yes, you can. And you can write your own serializers. I'm using the new API for that. It's a little bit different. It's from the Jest 21 2 months back. All of the plugins have two functions. The first one is called test. And any value will be passed to this function. If it returns true, this plugin will be used. If it false, it will propagate to the next plugins until it reaches the defaults. What I have here is that I look at an object and I look if it has isPlay property. And if it is, I will use a serializer to somehow show it nicely so I don't use the normal, maybe I can ignore things. Maybe it's a response and I don't care about the timestamps, so I remove them or serialize it somewhere else. This is really useful. Then when I have this plugin, I can either use it in single test or I can use it in all tests, depending what I want. I might actually be in favor of the first thing. When it's explicit, I'm using this plugin. Otherwise, it can be a little bit confusing how this thing got there. Why is this thing there? And then I can use it. You see here, I don't have to write anything. The two-match snapshot is the same. I have an object. It has some title. It has some other things. And please know that I put the play in an array. So it's not the object itself, but it's object inside an array, because these serializers work to the depth. And it looks like this. It looks nice, right? You get an array of displays. You get some custom information, and everything in the content is also generated, so you see everything you want. Sometimes, very often in React, you want to see a change in a component. So you have a change, you have a component with some default properties or maybe some initial state, and then you change something and you want to see that it's different. What you can do is that you can, like I do here in a simple example, do two snapshots before and after somehow. But then, in the snapshot files, I don't see that. I mean, I might see that the number changed or whatever, but it's not that pronounced. It's hidden. There's a package for that. It's called snapshot div. It's a special matcher which plays nicely with the snapshots. You include it as on the top. It's kind of easy, and then you say, I want to snapshot the difference between this and that. And what it does is kind of stupid. It just takes snapshot of that, snapshot of this, uses the kind of the thing you have in the Git for comparing two versions, and prints that thing. So you see there's a plus, there's a minus, that has changed. And this has to be the same all the time. Very useful for React. A question I get very often is that how does snapshot testing play with TDD? Because TDD is the big term, or BDD, whatever you want to call that, whatever flavor you prefer. It's different, and actually it's some antithesis of that, right? I here wrote some arguments like how it plays together. TDD is great for testing algorithms. You have two numbers, and the result is a third number, right? That's super nice. You have edge cases, you have some computation, and you know this before you start writing the function. That's important. With the snapshots, again, imagine writing a result of a component testing before writing component. It's like double the work, because you write a div, you write a div. You write a title attribute, you write a title attribute. You don't say anything. Snapshots are better for, I call it structures. It means something a little bigger, something where you don't, this is one unit value. TDD, obviously, you write before it. Snapshots, you can kind of conserve what you have. You can use it for refactoring. I use it for refactoring because we had a huge code base of React. We wanted to introduce something new, and we weren't sure that it wouldn't change things. So I kind of said, we have this, just take snapshots of every possible state, and let's compare how it goes with the new library. That was great. The other option is that you do it, as I see, concurrent. That's a great thing. You write, you save, and you see how the snapshot has changed. So you created a new div in your React, you see, and the snapshot has changed, and you say, yes, I approve this change. And you do this loop, very small loop, when you introduce new arguments, when you introduce new elements, and you see the changes, and you build it as you work. So it kind of conserves what you've written before. And you can take a picture of the whole thing, of the whole create component, let's say. TDD is, as I said, a small part maybe. You can maybe say, I want the return object to have a username of Charles, right? Here I want to snapshot the whole thing. What is important is that both of these are actually part of your code base. I mean, some people ask me, should I commit the snapshots? I mean, yes, that's the meaning. I mean, it's still part of the test. It's just you don't maintain it by hand, but you have a system that maintains that, but it's still part of your code base. When I talked about the snapshots and how you should use them concurrently, I mentioned the watch mode, and watch mode in Jest is just great. So if you have Jest, if you have it globally, you just pass watch attribute. If you have it in your npm, you pass it like that. That's good to know. It took me some time to discover that. Well, it works pretty well with Git. What it means is that it will look on the changes by default. It will look at the changes after the last commit, right? So uncommitted files. It will find which tests are affected by these files, and then it will run just these tests. So it's super fast. It only runs tests that could have been changed. And as I said, it's a watch mode, so every time you change something, it does this again. It understands the dependencies. I will show you a little bit later. It's important. It knows how JavaScript works, how imports works. While you are inside that, you can filter by pattern or test name. Path. Path. So you can say, I only want to run tests inside module A category or whatever, or a folder, or maybe only tests which include letter R. I have the mute for that. You can update the snapshots, and one really cool thing, I really love that, is that when you run something and something fails, these failed tests are run as first, so you don't have to wait for them to fail again, because you will be probably maintaining them. That's the pragmatic thing I was talking about. Let's see how it works. So this is an example how Jest understands the code. I have a test that imports a module A, and module A imports module B somehow and does something in between. When I change just module B, Jest understands it needs to run this test. That's a great thing. You don't have to tell it anything. It knows this test has to be rerun again. this is how a snapshot, a failed snapshot looks like in a watch mode. So I changed some numbers somehow, maybe it was computed, I don't know, and just said there's a problem. It looks different, and it says inspect your code changes or press U. So you either press U like update, it will save this new and you can work on, or you have to change your code to somehow remove this mistake. That's really cool. This is the example. Like I had 3 files, you know, but it's like one of the minimum I can show you on. I run it. I had a problem in the last. I fixed the problem, and it ran this file as the first one. Really cool feature. And you will, I mean, in my company, we have tests on my machine. They run for over a minute. This is a lifesaver. A third topic. It's called async. I had a presentation about this, like a specialized one. This is a small takeaway from that. Testing async is hard and it's tricky. I will show you why. You can either use callback. This is like the whole Jasmine style, and you can use promises like that and you pass it. Fortunately, Jest does this for you. So if you return a promise, Jest will do this magic for you and it will work. The thing is, you have to return the promise. Here I have 2 promises, but only one of them is returned. What it means, if the first one for some reason fails, this is what the console will show you. So first thing is, you see that there was some error, right? That's nice. The problem is, the whole thing passed, because this test wasn't like part of the test suite. The test already finished. This thing failed. There was a node error because you just encountered an error. But the test is passed. The return value is 0. If it's on the CI, this test will, like, nobody will see that there was a problem. That's what I'm talking about when I tell that testing async is tricky. And, oh yeah, I love this one. So when you want to catch, or I mean, you want to test that your promise can be rejected, and you should do that. I mean, if you have promises, you should also test the conditions under which are those promises rejected. You have this test. It looks good, right? I mean, it rejects, and I want to see that the rejected value, maybe the error has some format or whatever. I do that. Well, what happens when the test actually is resolved? Well, for Jest, they see, oh, there was something wrong. It doesn't get to the catch phase. And there was a fulfilled promise, no problem. You created a test that cannot fail, which, I mean, congratulations, but you don't want that, right? What you have to do to make it kind of work is do something like this. Like you can either write that you expect certain number of assertions, but then you have to maintain this number because when you add the new test, you have to increase it. That's annoying. Or you can put that then. So if it actually somehow fulfills, you return an error which will be catched, and you will get a lovely error which doesn't tell you anything. And you have to inspect the code and say, oh, it was actually rejected. What happened, right? Since some time, we can be using async await. The good thing is that this whole function always returns a promise. Just can handle promises, so that's okay. But it has some other problems. So here I have 2 promises. I mean, the code kind of looks like without promises. That's the whole point, right? What happens is that if you forget to maybe write one of those awaits because something, right? Maybe you change the API, something. What would happen, right? So you get this nice error. It says expected number but received object. I can't guarantee you will spend a few hours on that. Okay, maybe at least minutes, but it will surprise you. So be careful about that. You see, this is the same thing where I showed the promise. I want to test that under certain conditions this function rejects or fails. Again, I mean, now you are a little bit more educated and you know that this wouldn't work for a resolved promise as well, because again, if it was resolved, there would be no catch, everything is okay, no errors, just says this test is okay. Yeah, so if you resolve that, it will still work, and that's wrong. What you can do, oh yeah, I saw this so many times. You know, I mean, it works. Yeah, sure, it works. Yeah, it gets the job done. I mean, if that thing doesn't fail, you get to the next thing, it fails. You get a lovely error. True, it's expected to be false. I don't know. Yeah. Fortunately, and let me think. I think it's just 20. So it's kind of some time ago, a few months. There was a new thing introduced. It's called .resolve and .rejects, and it's supposed to solve these issues. It's a really small syntax. It's consistent, it's small, and it catches all these errors. So what you do is that you put this word either rejects or resolves before the matcher, and it will unwrap the promise, right? So it will take the promise, it will wait for the rejection or fulfillment, it will take the value out and compare it. So you can use anything. I mean, here I have to be, but you can use any matcher you have to match snapshot, to match object shape, whatever you want. That's also nice. The same is for the rejects, right? So you expect that the error has some shape. The good thing is that the errors are marvelous. I mean, they tell you what happened. They tell you, I'll write that, read that. Expected, received promise to resolve, instead rejected. And of course, if the error thing, which is so hard to test, expected promise to be rejected, instead it was fulfilled with this value. That's awesome. That's what you want. It's just, I will show it again, sorry. Just one line. It solves so many things, so many troubles. You see, you have to put a await there because you still have promises. You still kind of need to wait on this line. So yeah, it's still a little bit tricky, but it solves so many problems. That's what I showed you. That's what I was talking about. I mean, yeah, I'm really excited. I mean, I did commit a few comments usually to documentation, but I was looking at what is new and I tried to like look at it. I mean, people have amazing ideas. I love that. Like people put like so sometimes weird ideas, but some of them are actually good in the end when you think about that. And I've been looking at what is merged, and these are my favorites. So the first one is mock name. I don't know why it wasn't like discovered before. When you create a spy and then for some reason it fails, I don't know what, you get this error. You get jest.fn, and you don't know which one because you have 50 of them and you don't care about the content tenants and you have 50 spies in one test, whatever. This is not nice. So what you can do, what you will be able to do, sorry, and when the next Jest is released, is that you name this mock, right? What it means, instead of the jest.fn, you will see this name, you will know which mock is causing problem, you can delete it from your code base or fix the test. Snapshots, as I said, they are part of your code base, but they are in a separate file. I'm not sure if I mentioned that, which kind of leads you to the thinking, oh, that's something else, I don't have to care about that. There's a commit which enables, eventually, the editors to show snapshots at the place where they are like kind of called. So you can see on this line, this snapshot was generated, you can review it, you can like kind of see, oh yeah, that's cool, that's what I want, or something like that. Maybe even in the future to approve the changes inside the editor so you don't have to go to the console and press U. It will be like, I don't know, at least 2 keystrokes shorter or something like that. And this thing, sorry. Now, if you run a Jest and you pass, this is like the path regex, right? So you only want to run test inside packages module A. And for some reason, you misspell, and this thing doesn't exist, or you remove all the tests or something like that. And the test will say, it's okay, no, nothing to test, I'm okay, everything passed. The new version will have this reversed, so if it doesn't find, if it finds no test, it will be empty filter, it will fail, and it says, you probably did something wrong because I'm here for testing and you didn't pass me the test. You can, of course, override it with, I know what I'm doing, don't test anything, I have you here because I want to have like a sticker of Jest on my laptop, but I want to use that one. Oh, this is a lovely GIF I found. I'm sorry, I don't remember the guy name who tweeted that, but this is unit test, right? I just want to remind you that what I told you, it doesn't guarantee your application works. right? It makes sure that these black boxes, in this case actually black, do work as they should, but you still need to introduce more tests and integrations and everything and end-to-end tests, and this is just small part. It's the most funny part because it's fun, but it's just one part. Here are some resources. There are some articles. There's links to my previous speech about Jest. I will share this so you can you don't have to take a picture of it now. What I want you to do is that I want you to go around. I want you to go to your colleagues, go to weddings, and just talk about Jest with them and make them go, Jest can do what?